Dear students, firstly I will introduce myself. I am myself Professor Sid Chaubey, working as assistant professor in electrical engineering department of SND College of Engineering, Yola. So students, what we are studying up to 11, 12 lectures, what we have studied, we are going for the high voltage engineering. In the high voltage, up till now, what we have studied the breakdown in the gases, breakdown in the liquids, breakdown in the solid dielectric. Again, what we have studied the different methods concerning with the generation of the high voltages and the high currents, right? But now what we are studying the generation of high voltages and the currents. So in the last lecture, I have told you that there are 4 methods for that one, for generation of the high DC voltages. Firstly, what we have studied the Tesla coil, we have studied the resonance transformer, we have studied the cascade transformer. What are these? These are nothing but the methods to generate high AC voltages, right? Now in the second case, what from AC to where we are going to shifting? Surely we will shift from higher AC to DC. Now what we are going to study? We are studying the generation of the, see here, generation of high voltages and current. And in this case, we are studying the topic that is the full wave rectifier circuit. In the last lecture, what we have seen? In the last lecture, we have surely seen the half wave rectifier circuit. So why it is essential to go for the full wave circuit? Because the reason is that in the half wave circuit, the efficiency is very less, that is only 40.82%, while in the case of half wave full wave rectifier circuit, it is going to be near about 80%. And also the ripple factor in the case of full wave rectifier circuit is going to be lower as compared to the half wave circuit. So what is the difference between the half wave rectifier circuit and full wave rectifier circuit? See here. What say full wave rectifier circuit is electric circuit that convert AC to DC are known as the rectifier. In the first lecture, I have told you what is the rectifier. In two types, half wave rectifier circuits and full wave rectifiers. Significant power is lost while using a half wave circuit. Just I have told you that efficiency is very low. In the case of loss is more, it means you can, any machine, if loss is less, it means you can surely say that the efficiency of that machine is low. So here the losses are less, so it is going to be more useful or more economical, that is going to be the full wave rectifier circuit. And this half wave rectifier circuit is not feasible for application that need a smooth and steady supply. What I have told you in the last lecture, that we are using the filter circuit. Why? To get the smooth DC supply. That is going to be the distorted DC supply to full smooth DC supply we have used that. So these are the advantages of the full wave rectifier circuit. Now, what is the when we study the full wave rectifier circuit? What we are going to see? In spite of, in the case of half wave rectifier circuit, we use only one diode, but in the case of full wave rectifier circuit, we are using the 2 diodes. Now, can anyone tell me what is the reason why in this case full wave rectifier circuit 2 diodes are used? Because when we have seen the half wave rectifier circuit, diode is single diode is going to be used, and I have already told you that diode is nothing but a unidirectional device. It works or conducts in only forward bias condition. It does not work in the backward bias condition. So in this case, there is going to be half wave. So for this purpose, in the full wave rectifier circuit, we are using the 2 diodes. When first come in the reverse bias, second come in the forward bias. When second come in the reverse bias, first come in the forward bias. So see the diagram is going to be here. A full wave rectifier circuit is defined as a rectifier that converts the complete cycle of alternating current into pulsating DC. Unlike half wave rectifier circuit that utilizes only the half wave of the AC input, full wave rectifier circuit utilizes the full cycle. The lower efficiency of the half wave rectifier circuit can be overcome by the full wave rectifier. What I have told in the start of the term, that efficiency of the full wave rectifier circuit is greater, that is double. You can say that it is double to that of the half wave circuit. So we'll see the diagram. Here see the diagram. 2 diodes are here. This is D1, see here. This is a D1 and this is D2. This is a tap transformer. It is going to be done. See here, I is equal to I1 plus I2. Why it is called as I1 plus I2? See the diagram. I1 plus I2. Why it is called as? Firstly, when I1 will be occurring, when D1 is forward bias and I2 is flowing, the I2 is flowing when the D2 is in the forward bias. So it is called as a full wave. See the diagram, last diagram we have seen. That when we have seen the diagram of half wave rectifier circuit, what we have seen? That only the half wave is going to be rectified. In this case, see that the full wave is going to be rectified. So it is called as the full wave rectifier circuit. See in the diagram, we are seeing this is full wave. In the last diagram, when we have half wave, we are saying that only the half wave is going to be rectified. Working of a full wave rectifier circuit. See here, the input AC supply to the full wave rectifier circuit is very high. The step down transformer in the rectifier circuit converts the high voltage AC into low voltage AC. And the anode of the center tap diode is connected to the transformer secondary winding and connected to load resistor. Just see what I have told. During the positive half cycle of the alternating current, top half of the secondary winding becomes positive, while the second half of the secondary winding becomes negative. It means D1 is positive and D2 is negative. Just I have told you that. Just 2 minutes before I have told you that D1 is coming conducting, D2 is non-conducting. When D2 is conducting, D1 is not conducting. This is called as the full wave rectifier circuit. देखो यहाँ पर लिखा है. During the positive half cycle, diode D1 is forward bias and it is connected to the top of the secondary wire. But D2 is the reverse bias. Just I have told you that D2 is reverse bias and D1 is forward bias. So it is connected to the bottom one. Due to diode will be acting as a short circuit and D2 will be conduct as the open circuit. Why? D1 is short circuit because it is the conducting state. Why? Because open circuit because in the reverse state. Reverse state means there is no flow of the current. During the negative half cycle, the D1 is reverse bias and the diode D2 is forward bias because the top of the secondary becomes negative in the bottom. Just I have told you that when D1 is positive, D2 is negative, D2 is reverse bias. When D1 is positive bias, forward bias, D2 is reverse bias. When D2 is forward bias, D1 is negative. This is a simple principle of that. Now we will see the advantages of full wave rectifier circuit. What are the advantages of the full wave rectifier circuit? The rectifier efficiency of a full wave rectifier is double that of, just I have told you that, half wave rectifier circuit. The efficiency of the half wave rectifier circuit is 40.6%, while just I have told you that, while the rectification efficiency of full wave rectifier is 81.2%. And here I also show that I have told you the ripple factor in the full wave rectifier circuit is low and the simple filter circuit is used. The value of ripple factor in full wave rectifier is only 0.482, while in the half wave rectifier it is going to be 1.21. The output voltage and the output power obtained in a full wave rectifier circuit are higher than the obtained in the half wave rectifier circuit. The only disadvantage of the full wave rectifier circuit. Can anybody tell me what will be the disadvantage? Anybody can think? Here more elements are used as compared to the half wave rectifier circuit. In the half wave rectifier circuit, we are only one diode. In this case, we are using two diodes. In the half wave rectifier, we are using simple transformer. And in the case of full wave rectifier circuit, we are using the tap transformer. Just in the diagram here. So, okay, students, we are going to see now in the next lecture, we will see what is the voltage doubler circuit.